Remember when we say that we can't take the square root of a negative number, because there is no real number that will square to produce a negative number. But according to the definition of imaginary numbers, an imaginary number when squared gives a negative result. Let's try squaring some numbers to see if we can get a negative result. 2 into 2 is 4. Negative 2 into negative 2 is positive 4. 0 into 0 is equals to 0, and so on. There is no chance to get negative result. The square of numbers, whether positive numbers or negative numbers, is always positive. The square root of positive 1 is 1. But what about the square root of negative 1? Is the square root of negative 1 exists? Well, there is such a number called I for imaginary that can do this. I into I is equals to negative 1. By taking square root on both sides, we get the value of I is equals to the square root of negative 1. So the square root of negative 1 is equals to the I. This notation I, called iota, is the foundation for all imaginary numbers. So the square root of negative 9 is equals to 3i, because negative 9 equals to 9 times of negative 1. So this radical could be split up into root 9 times root negative 1, which is therefore 3 times I or 3i. Similarly is for square root of any negative number. Now, let's consider some situations where we use the concept of imaginary numbers. We know that when x squared minus 1 is equals to 0, the x is either equals to 1 or negative 1. But how could we find the solution if x squared plus 1 is equals to 0? Here we use the concept of imaginary numbers. If the discriminant b squared minus 4ac is negative, we say the solution is not real. Similarly, when finding the solution of quadratic equations using the formula, if the discriminant b squared minus 4ac is negative, we say there is no real root of quadratic equation. If you have any questions, please feel free to ask me in the comments. I will answer in the upcoming videos. If you like the video, please like and subscribe.